Hi everyone. Today we are going to do a types of chemical reactions lab. And this lab is going to be done in class by the students who are in class. But if students are unable to be in class for some reason, then this is a great video for you to go through to help you answer the questions on the lab. So for those of you who are in class, what's going to happen is you're going to show up and you're going to have a lab set up in front of you. So at your lab station, you're going to have a test tube rack. So this is going to be your test tube rack, this blue thing right here. And your test tube rack is going to have some test tubes in it. You're going to have 1, 2, 3, 4, 5, 6, 7 test tubes. And those test tubes have been labeled with different chemicals. You're also going to have a waste container that I'm going to put aside. Okay. And that's going to be for all of your waste throughout the experiment. You're going to have a beaker filled with water. You're going to have some test tube clamps. You're going to have a test tube clamp, which is this right here, and that's going to be used to hold your test tube. Okay, when you're heating it, you're going to have 2 strips of aluminum foil, some wood splints right here, and then you're going to have a battery, some alligator clips. This is going to be a striker. That's going to be to start your Bunsen burner. You're going to have a Bunsen burner. I have my Bunsen burner right over here. And then you're going to have some tongs right here. That's going to be to hold different materials that are going to be burning. And then you're going to have a stack of little cups. And each little cup is labeled, and it's labeled in order. So you're going to have magnesium, and it's labeled magnesium A1, and that means that it's reaction A number 1. And then you're going to have some iron, and iron is going to be labeled iron A number 2. Then you're going to have some copper. Copper is going to be labeled Cu. C number 1 for lab number 1. And finally, you're going to have Zn for zinc, C number 2. So those are the different materials that you're going to need for this entire lab. Okay, so let's get started. You're also going to have your lab handout in front of you. That's going to be at the lab station for you, and it's going to give you instructions to the lab, and then also going to give you some the procedures for each step. So that's going to be right here, and that's going to be at your lab station. So some pointers that I have included. Number 1, the purpose. The purpose of this experiment is for us to observe the 5 basic types of chemical reactions. That's the main purpose of this experiment. So as you're going through the lab, what you should be doing is reading the instructions on the lab table and answering your questions in your Chromebook as you go along with the lab. Okay, some general procedures for you. Each lab station has been set up with the materials for you. Carry out the reactions using the appropriate quantities and reagents suggested unless otherwise stated. Use the test tubes. When heating reagents and test flame, must make sure that your test tube is opening pointed away from other students. And heat the test tube at the surface of the material and work downward towards the bottom. Be sure to record your observations, balance the equations, and write the word equation as you go. And then discard all solutions and everything either in the drain or you have your waste container. Also, it's very important that everyone leaves their lab station cleaned up, as nicely as it was when you got into class, because it's going to make the ease of transition during this time much better. Okay. One thing I forgot to state is you also have your scale. You're going to use your scale. I have my scale right over here, and you're going to use your scale for reaction type B. It says station 3. It's going to be lab number 3 that you're going to do, but it's reaction type B number 1. Okay, so let's go ahead and get started. What we're going to do is we're going to look at reaction type A. Reaction type A says use crucible tongs, hold a strip of magnesium ribbon, and ignite it in the burner flame. So first thing that we're going to do is we're going to light our Bunsen burner. So I'm going to turn on my gas, and then I'm going to take my striker, okay? So when I look at my Bunsen burner, right here, I can adjust my oxygen that's coming to my flame. Right here, I can adjust the amount of gas that's coming to my flame. And then this is my striker. I want to make sure that I get enough friction to make a strike or to make a flame, like a tiny spark almost. Okay, so I'm not getting enough of a spark, so I want to make sure I create enough friction. So I want to push down with one and pull back with another to get that flint to go. Okay, I'm going to put this back over here and go ahead and get that started. Okay, and so once I get that started, I'm going to adjust my oxygen a little bit so that I have more of a blue flame. And some of the test tubes or some of the Bunsen burners won't adjust very well. Try to get it to adjust the best that you can. This Bunsen burner that I'm using will not let me adjust the oxygen, so I'm going to use it as it is. I'm going to take my magnesium. Magnesium is Mg. And I'm going to, so my piece of magnesium is just kind of like this little silver piece in my hand. It's kind of hard to see. And I'm going to put that on my tongs, my crucible tongs. Okay, just like this. And then I'm going to hold that into my flame. Now, when you're doing this in class, make sure that you're not looking directly at that flame while you're doing it, okay? And you're going to make observations. So make observations from kind of the side, from a side point. You want to make sure that you have the magnesium in the blue part of the flame. And it might take a moment to get going. And there you go. So it makes like a bright, like super bright white flame, okay? A super bright white, and then what's left is going to be kind of this, it's like a white powdery almost material, if you can see that, okay? So make your observations on that. So we had a bright white flame, very bright white flame, and then you had a solid white powder left over. You want to make sure that you write your balanced chemical equation. We have magnesium reacting with the oxygen in the air to produce magnesium oxide, okay? Make sure you write your word equation, you do your balanced equation, and you include your observations, okay? The next one, lab station number 2, says slightly pull apart a piece of steel wool. Your steel wool is already kind of pulled apart. That's your Dixie cup labeled FE, okay? FE, it's for A number 2, and this is your steel wool. And we're going to make some observations. It says use crucible tongs to heat the piece of steel wool, which is iron Fe, strongly in the Bunsen burner for about 30 seconds. So I'm going to go ahead and bring that over, and you can see some pieces are kind of falling off a little bit, but it's definitely burning there. I'm going to burn that for a little bit. Okay, and you can see, like I said, these little pieces falling off, but you can see the flame going through the piece of steel wool really well. Okay, and then in the end, what you end up having, so the steel wool was like a light gray, like a light gray hair almost, okay? Now, when I take it out of the flame, I end up having a much darker, and it's, again, it's hard to see on this camera, but you have kind of a darker clump of a darker gray right there. So we have the iron reacting with the oxygen in the air again as we heat it. The iron reacting with the oxygen in the air to produce iron oxide. Okay, this is actually a sped up reaction of what happens when something is rusting. Okay, this is the sped up process of rusting. We're rusting iron. We're turning iron into iron oxide. Okay. And then for your waste in those cases, you can just stick your waste in the Dixie cups, okay, in the little Dixie cups, and then you can end up just throwing those away when you're finished with the lab, okay? Now we have reaction part 3. It says place a very small scoopful of solid sodium hydrogen carbonate, which is sodium bicarbonate, which is the same as baking soda, okay? That's actually already in your very first test tube to the left. So your very first test tube, it's labeled NaHCO3. It's for reaction B number 1. Okay, and it's a white powdery substance. If you've ever looked at baking soda before, or you have baking soda at home, go into your kitchen and observe baking soda. And it says find the mass of the test tube with the powder. So I'm going to turn on my scale, okay, and I'm going to find the mass of that. And while I'm finding the mass of that, I'm going to read all of the instructions because everything kind of happens pretty quickly. So it says heat the sodium hydrogen carbonate in the test tube for 1 minute. Observe any changes that occurred during the heating. Toward the end of the heating, light a wood splint and insert the flaming splint into the mouth of the test tube. Okay, so I'm going to record my mass here. My mass right there is 9.74. So I'm going to record that on my lab that I am doing. So 9.74 grams. And then I'm going to take my tongs, my test tube tongs, okay? I'm going to grab my test tube and I'm going to heat my test tube. Remember, we want to heat at the surface, okay? Heat at the surface. And I don't want to point my test tube towards any students, okay? So I'm pointing it away from me. I'm heating right there at the surface of the sodium hydrogen carbonate or sodium bicarbonate, also known as baking soda. And if you look really carefully, you can actually, let me see if I can get that a little bit closer. You can see a little bit of condensation on the top there, which condensation, that liquid right there at the top of the test tube, is indicating that there's some kind of water being released, okay? And at the end of my heating, towards the end of my heating, I want to figure out what a wood splint is going to do. So I'm going to take a wood splint, I'm going to take this piece of wood and I'm going to stick it into my flame so that I can get that to be burning. And then I'm going to bring it close to my test tube and I want to bring that down. And what's going to end up happening is I hopefully you can see a thicker white smoke was produced. And so really what that is that's carbon dioxide actually burning in the wood splint, okay? And when you're finished with that reaction, go ahead and take that into your waste container and tap that out really well for me, okay? Because what I'm going to do is I'm going to refill these test tubes for the next set of classes, okay? And so I'm just gonna set that right there in the test tube rack, okay? Don't touch the test tube. The test tube is going to be hot, okay? And then make sure that you write your observations and that you balance your reaction and you write the word equation there. So you have sodium bicarbonate or sodium hydrogen carbonate is going to decompose. It's going to break down. What does it break down into? Balance the reaction and name the components of that, okay? And now we're going to move on to reaction B number 2, which is at station number 4. If you were in class, how I would do this is I would rotate you to different stations, but instead, because of the times, what we're doing is we're doing the same exact reaction at your own lab station, okay? Okay, so station number 4 says fill a 150 milliliter beaker halfway with water and place about 5 drops of universal indicator. Your lab doesn't say that. I took off the universal indicator because I didn't think that it was beneficial in this lab. So I'm going to actually turn off my flame because I don't need my flame right now. And I'm going to move my Bunsen burner to the side. Okay, and then I'm going to bring over my water. And what I'm going to do with my water is I am going to also take my battery and I am going to connect my battery to my alligator clips. So I have my alligator clips right here. I have one alligator clip and then I have a second alligator clip. And what I'm going to do is I'm going to connect those alligator clips. So I have an apparatus that looks like this. I have 2 pieces of aluminum foil, and the pieces of aluminum foil are connected to my battery, okay? And then I'm going to take my aluminum foil and I'm going to stick it into my water. Okay, so when I stick it into my water, all of a sudden I start to see tiny, tiny, tiny little bubbles that are being produced at the bottom of the aluminum foil. So if you look really carefully, okay, you can see these tiny bubbles coming from the bottom of the aluminum foil. Okay, so what's happening there, and you might want to see if you can find a video of this a little bit more clear. But what's happening there is I'm running electricity through my water, and that's causing my water to break down. I am legitimately decomposing water there. I'm breaking water down into its components, okay? So that's what I've done. I have created hydrogen and oxygen gas. Now, if you look at this beaker of water, you can't tell that there's hydrogen and oxygen gas because it's evaporated. But in this case, I have water, I'm running electricity through it, and I am producing hydrogen gas and oxygen gas. Okay, so hopefully that is what you saw there. And we're going to move on to our next activity. Okay, I'm going to move my water aside and my alligator clips aside because I no longer need those. Okay, now I'm going to move on to reaction type C. Make sure that as you're going along on your document, you are balancing your equations, writing your word equations, and you are writing down your observations. Okay, so this next reaction is actually probably one of my favorite ones. This is reaction type C and reaction type C number 1. Reaction type C number 1 says, place a strip of copper in a test tube with enough AgNO3 to cover it, okay? So what I've already done is I've already set out the AgNO3 for you. So here's your AgNO3, and then I've also set out your copper. Now my copper strip is going to be longer than my AgNO3, but I'm going to go ahead and just drop this in. So my copper is definitely like a copper color, what we would call copper, and then we have a clear solution here of AgNO3, and I'm going to drop that in there. Okay, so this is my copper and my AgNO3, and I'm going to let that react a bit, but you can see it immediately. You can see all of a sudden there's like what looks like bubbles, but it's not bubbles. It's actually a solid that's forming on the outside of the copper, okay? So it's a solid that's forming on the outside of the copper. And I'm going to let that react for a little bit and come back to that so you can see just how much of that solid that's being produced is. And if you think about it, okay, so I've got silver nitrate, AgNO3, reacts with copper solid to produce. Well, what's happening? This is a single displacement reaction. So our metals are going to displace each other. So if copper displaces silver, then what am I producing? I'm producing copper nitrate, and then I'm producing silver solid. And so what I love about this reaction is we're actually producing solid silver particles. Okay, we're going to come back to that to see the observations, make better observations in a little bit. Make sure that you have balanced your equation, you've written your word equation, and you've written down your observations. Okay. Now, while that is reacting, we're going to place a couple of pieces of mossy zinc metal in a test tube, approximately a quarter of the way filled with 3 molar HCl. Place a stopper loosely on the test tube. After 3 minutes, light a wood splint and insert the flaming splint into the mouth of the test tube. So I'm going to go ahead and take my stopper. So everyone should have a stopper at their lab station. Make sure that your stopper is big enough to not fall through. And then everyone should have, this is their zinc. So ZNC number 2, because it's lab C number 2. And I'm going to take those pieces of zinc. I'm going to drop them into my test tube. And I'm going to let them react, okay, to the best of their ability. So right here, my zinc was more of like a silver color. It looked like a silver metal, okay? And I have my hydrochloric acid in there, and you can actually see bubbles coming up from that, which means that the hydrochloric acid is reacting with the zinc. Hydrochloric acid reacting with zinc. And again, this is a single displacement reaction. So what I have being produced is I have the hydrogen and the zinc are switching places, basically. So I have hydrogen gas is produced, and then I have zinc chloride is going to be produced. And something to remember, zinc always has a +2 charge. So when you're writing your balanced chemical equation, recognize that zinc always has a +2 charge. But you can really see those bubbles starting to form. So I'm going to let that sit and react a little bit. And I'm going to come back to my silver, because here's my silver nitrate, and you can actually see I'm producing copper nitrate, and hopefully you can see this. Maybe if I gave you a white background, you can see that there is a blue hint, a blue color that's being produced. And that actually is your copper nitrate. And then as I shake it, then what ended up happening on the bottom here, if you can see, you have that solid silver particles right there. And that's just going to continue to react while I'm going through this lab. I'm creating more silver because I took the silver metal off. And so I exposed more copper to that silver. And you can see that that solution is getting more blue also as you go on. So make sure that you add that to your observations. Now, since my zinc and my hydrochloric acid are reacting, I'm going to go ahead and start my Bunsen burner again. And when I start my Bunsen burner, I'm going to use it for another wood splint, okay? So I started my Bunsen burner real quick, and I'm going to add a wood splint to that so that I can get a flame into my hydrochloric acid zinc solution, okay? And I'm gonna stop talking real quick so you can just make observations of what happened, okay? So I'm gonna light this on fire. Did you hear that pop? Okay, hopefully you heard that pop. If not, you can go ahead and rewind it. Hopefully you heard it when you were in class doing your reaction, but that was a pop. Now, when I light hydrogen gas on fire, it is going to react, it's going to explode. And the reason it's going to explode is because hydrogen gas is going to react with the oxygen gas in the air to produce water. Okay, so that's another example of a reaction that's not on your sheet, but it's H2 plus O2 yields H2O. So that's actually going to be a synthesis reaction or a combination reaction, okay? So that was reaction type C, number 2, okay? Now we're going to move to reaction type D. And I'm actually going to move my flame to the side a little bit because I am going to use that coming up, okay? And my reaction type D, number 1, says add a small pipette worth of 0.1 molar AgNO3 to a test tube to a depth of about 1 centimeters at a similar amount of CaCl2. So you have two test tubes here. One is AgNO3 and one is CaCl2. Both of them are clear solutions, clear liquids. Now what I'm going to do is I'm going to pour those two together. I'm going to add the CaCl2 to my AgNO3. And as I do that, did you see what happened? Okay. I'm sure you can see that. And if you can't, I'm going to use a more brown background so you can see. Okay. That is a white powdery substance has been produced. So I had two aqueous solutions. Aqueous means dissolved in water, and it produced a solid in the end. That solid produced by two aqueous solutions is called a precipitate. A precipitate is what's formed when two aqueous solutions react with each other to produce a solid, and the solid is the precipitate. And that's pretty crazy. So let's think about that. And it kind of looks like a cooked egg white almost, is how I would explain that. So I have AgNO3 reacts with CaCl2. So the Ag and the Ca are going to switch places. So now we're going to have CaNO3 so calcium nitrate, plus AgCl. And then go ahead and balance that. That's going to be silver chloride. So what we created here, if we were to filter that out, that white substance is called silver chloride that we produced. Okay. And a precipitate basically is formed because it's not soluble in solution. Okay. Meaning it will not be able to dissolve in solution. Now, station number 8 on your lab, or reaction type D, D number 2, is place a small scoop of solid sodium carbonate in a test tube to a depth of about 1 centimeter. Add a pipette of 3 molar hydrochloric acid. So I have my solid sodium carbonate right here. It's labeled for you Na2CO3. And I'm going to add my 3 molar hydrochloric acid. And then it says after I add that, while the reaction is occurring, test with a flaming splint as done in station 3 and check out your reaction. So I have sodium carbonate and I have hydrochloric acid, and I'm going to add the two together and watch carefully at the bottom of that test tube. Okay, so I definitely had, I had some kind of gas was released. And if I heat my burning splint and I put my burning splint in there, I'm going to have that same thick, dense smoke. Okay, the flint was set out, and then also it was this thick, dense smoke, just like we had at station number 3. So that again is an indicator that there's carbon dioxide in the air. Okay, is that kind of reaction. Okay, now your last reaction is a reaction that is not at your lab station. The last reaction is going to be your alcohol burning, and I'm going to go ahead and do that as a demonstration. The students who are in class are going to watch the video rather than you guys doing that yourself. And hopefully all of this was helpful. Make sure that you balance your reactions, you write your word equations. This lab is very detailed. It should take a little bit of time, but hopefully you enjoyed going through it and through the different types of chemical reactions. Okay, so for my very last reaction, I'm going to do reaction type E, which is a combustion reaction. Combustion reactions are the reaction of a hydrocarbon, so carbon and hydrogen containing compound reacting with oxygen in the air to produce carbon dioxide and water. So what I have here is I have isopropyl alcohol, which is rubbing alcohol, and I am just going to put a flame on top of it, okay? And what happens when you put a flame on top of rubbing alcohol? It is going to end up burning, and you can see that flame. And as that's burning, what I can also do is I can place a watch glass on top of it. And when I put the watch glass on top of it, what you can start to see at the very bottom of the watch glass is you can start to see some condensation. And that's because when you have isopropyl alcohol or rubbing alcohol or any hydrocarbon reacting with the oxygen in the air, what ends up happening is you produce carbon dioxide and water. So at the very bottom of that watch glass, I am going to have a production of water. Okay. So I could actually take that and I could wipe it, and I'm going to basically wipe off water, and I have water on my finger. Okay. And it's actually dripping onto the table a little bit. Okay. So that's the reaction of isopropyl alcohol and oxygen in the air to produce carbon dioxide and water. And the water is what's collecting on the bottom of this watch glass right there. Okay. Now, another thing I wanted to bring your attention to while that burns, okay, is if you want to take a look at, this is again my silver and my silver nitrate and my copper. So you can see it's a deep blue now, and I have produced a real fuzzy substance, and that fuzzy substance is a solid silver that's being produced. And I can tap it on the bottom, and when I tap it, those pieces start to flake off a little bit, flake off of the copper, okay, to fall onto the bottom of that test tube. Pretty cool, if you ask me. Hopefully you enjoyed this lab activity, and reach out if you have any questions.